Hello, everyone, and welcome to today's SANS webcast, Osquery, a modern approach to CSIRT analytics, sponsored by Upticks. My name is Carol Auth of SANS, and I will be moderating today's webcast. Today's featured speakers are Dave Shackelford, SANS analyst and CEO of Voodoo Security, and Milan Shah, CTO of Upticks. If during the webcast you have any questions for our presenters, please enter them into the questions window located on the GoToWebinar interface at any time. Please note that this webcast is being recorded, and a copy of the slides and recording of this webcast will be available for viewing later today and can be found on the SANS registration page. And with that, I'd like to hand the webcast over to Dave.
Awesome. Thanks, Carol, and hey, thanks everybody for being with us today. I'm super excited to be able to really introduce this topic and really to introduce Milan and the crew over at Upticks, who are going to give you guys a really deep and sort of interesting bit of insight into new ways to handle endpoint and system level security analytics and processing and really event management and the whole thing, right? So that's what's really cool about this, is just to see what's progressing in the industry and how things are moving, because there are a lot of really sort of challenging problems facing us that are really forcing us to modify the way that we're doing things. So, hey, I'm Dave. Milan's coming up after me. Let's move right into the presentation. And, you know, the whole concept of this is really being driven by what's happening at the endpoint today. And when I say endpoint, I don't just mean desktop or laptop. You know, this is really system level, situations that we're encountering. And if you go back to the most recent SANS, protection and response survey that looks at what's happening out there with regard to a lot of the endpoint problems, I think the story is pretty obvious, right? We've got a lot of, really almost half of people that said they had been compromised. That doesn't surprise anybody today. We certainly saw a lot of this, and we'll continue to see a lot of this. But the other statistics are a little more interesting, in my opinion, right? Because 20%, 1 out of 5 people came back and said, hey, we didn't really know if our systems had been compromised at all. In fact, a lot of organizations have come back and said that they were only, told that they had problems at the endpoint by a third party that came and told them so. That's never how you want to find out that you have a compromised system or a set of systems in your environment. So that's not good. And what we also saw on the other side, so I think a little more positive information, is that another 1 in 5 said, hey, we found issues by proactively going out and doing some hunting exercises and activities that gave us that information before we were informed of such. So I think there's some good happening, there's some bad happening, but sadly, what we're really finding is that the scale of the workloads we're dealing with, whether that's on-premise or whether that's in cloud, is sort of really reducing our capability to, traditionally at least, respond or monitor things appropriately. And there's some interesting aspects to that, and I want to just introduce that topic, because what I certainly focus on these days is public cloud and things like AWS and Azure and Google Cloud Platform, and how people are deploying workloads into those environments. And one of the big shifts that we've tended to see is that people are moving towards this concept of shorter term assets. In other words, we're not running systems for months or years anymore. Now, granted, we still have some of that. That's internal mostly. But in the cloud in particular, we're seeing people start to run systems for shorter and shorter time frames. While that sounds great because, hey, these systems are being updated as an image and then propagated out, there's a downside to that. And for security in particular, there's a significant downside potentially, in the sense that we've got some really big challenges just monitoring and getting the visibility into those systems. If a system's only alive for minutes or hours, what does that mean to us? How do we actually track that? And if you're using traditional types of scanning tools or even investigative mechanisms or controls, then that might not work very well for you. So that can be really challenging, and just monitoring these over time has proven very, very difficult. Now, that's one side of it. The bigger side, and probably the most prevalent scenario that we've heard back from people in the community is that it's more of an after the fact situation that's coming back to bite us. It's, hey, I found out that there was a system that was online for 17 minutes and it happened to do something really bad in those 17 minutes, whatever that might be. And you'll get that through logs and some other things. But let me ask you, I mean, if you guys are in the position of having something alive for 17 minutes and find out through a variety of means, typically logging or some after the fact sort of system, that it did something bad, what do you do about that? Well, how do you collect artifacts? How do you get evidence from those systems? And so this ephemeral nature of systems that are running, particularly in the cloud today, is really causing us to have to revisit how we collect data and evidence and try to do so in a much more proactive and real-time sort of manner. So that's one factor that's starting to cause us a lot of headaches. Another headache that's, I'd say somewhat related is actually containers. And I've given, whole presentations about containers and container security, but it's a similar scenario, really. You've got an operating system with some sort of kernel integration through Docker or some other sort of agent or daemon, and it's hosting these sandboxed application environments that are sharing the OS binaries and libraries and stack underneath. Well, unfortunately, that can really limit the way that we're able to monitor continually, of course, as well as gather evidence and data that is running in any one of these containers at any time. So, do we need to enable auditing? Of course we need to enable auditing, but that's not always easy to do, and it can certainly cause performance, issues. We also need to have better detection and response within these container systems. And again, at scale, this is really challenging. And particularly in the cloud environments that we operate in, you might not have that low-level sort of access or integration to the container OS itself that facilitates this. So it leads us into this, really desperate, I'd say, need for better continuous security monitoring and the need to really go and do proactive hunting to really be able to look at systems both in the cloud and, on premises, and to be able to grab the system state and other forensic or response type attributes much more rapidly and maybe in a more continuous fashion. In addition to that, just the tactical issues of going and grabbing that data can be really problematic. Just finding the systems, tracking the systems, enabling those systems to be able to grab things and pull it back. So that's one aspect of this. But the other part that really sort of shakes out is just the operational nature of doing all this in the first place. How can tier one analysts rapidly look for things? And while I don't presume to say that it's always going to be a tier one analyst in this position, we really don't have the manpower in many SOC teams to be able to enable a tier two or even three type analyst to go always be scouring the environment for things. And so it might be the lower level or tier one, maybe less experienced analysts that have to keep an eye on the house all the time. So we need ways to help with that. We also need to be able to scale quickly. Neither of these are easy problems to solve. And especially if you're in a big organization that has a hybrid cloud with not enough people and lots of systems, that's going to continually prove to be a problem. So I actually have a quick case study to give an example of this. One of my clients, I'm a consultant by trade, had exactly this scenario. They have thousands of systems in the cloud, both containers and typical instances of workloads. Lots of internal servers and containers too. So they had a continually connected environment with both of these needing to interoperate, limited staffing, and what they were finding was that their traditional security tools at the endpoint were just absolutely failing them. Performance was a huge issue. Their costs were absolutely skyrocketing. And in fact, some of these endpoint tools were, almost wholly incompatible with some of the environments that they were operating in. And so they really had to start looking for some newer, more lightweight options that enabled them to do this kind of monitoring, tracking, and querying vastly more effectively. And again, it sort of led them into a situation where they said, well, what are we going to do? And that led them to some new solutions and some different platforms that, got the job done, albeit a bit differently than most people might have been familiar with. So with that, I'm going to hand it over to my friend Milan, and thanks for listening. Thanks for coming, folks.
Thank you, Dave. This is Milan Shah. I'm co-founder and CTO at Upticks, and precisely as Dave was talking about, these kinds of issues surfaced on our plate a few years ago, and we thought of doing something about it. It was a very interesting problem to really think about and mull over. So the first thing that we sort of locked in on was an open source project called Osquery. So what Osquery is an open source agent that was released about 3 years ago by Facebook to the open source community. And what it is a very simple, intuitive idea, right? So the idea there is, instead of getting data from the systems using the plethora of tools that the command line tools usually, or admin scripts and bash scripts and so on and so forth that we typically use today, the insight was, why don't we collect information in the form of SQL tables using standard SQL queries, right? So this was expected to have the effect that it standardizes data collection. It makes it significantly easier to deal with the amount of data coming back, because we can apply all of the SQL tools that we have built for normal data processing to the actual system data as well, right? So that's what Osquery really does, And most importantly, again, to Dave's point, right, what has happened in the industry in general over the last 20, 30 years, ever since the computing industry has really started, is we have sort of purpose-built agents, right? And this is, it's very natural to do it. Let's say I'm going to build a compliance solution or a file integrity monitoring solution, right? So I'll design the overall solution, and then at the end of the day, a part of my design will say, well, in order to solve the file integrity monitoring problem or the compliance problem, I need to build an agent on the system that extracts this kind of information for my solution, right? What has, of course, happened in the world is, because that's sort of the top-down approach, design approach that we tend to take, what has happened is you end up with a plethora of agents, which, in the world of cloud and container especially, it's actually not feasible to run so many different agents on the endpoints and so on, not to mention cost and so on and so forth, right? So Osquery was built with the exact opposite intent. So it was built with no particular purpose in mind. Instead, it was built for the explicit purpose of being able to export and retrieve all system data. What you do with the data, it doesn't really care about. Its job is to allow you to retrieve any and every piece of system data that you could ever imagine, and do so in an extremely optimized manner. So that's what Osquery is really all about, and we'll give you a short demo of Osquery for those who haven't seen it before in just a couple of minutes. So given this ability to now have this universal agent that runs everywhere and that allows me to extract system data using standard SQL syntax and so on and so forth, and then the overall problem now becomes, how do you really use this at scale? So as typical cloud environments, especially, because it's compute on demand, it is infrastructure as a service type of thing, it's all software driven, tends to be, typically much larger than a normal on-prem. Why? Because to create new instances, virtual instances on Amazon, is just a matter of writing some script and increasing the size of the for loop, and it'll create a whole bunch of new machines for you type of thing. So you tend to have very large environments, and so the Osquery solves one part of it, which is you can now have an agent on every one of those instances. But then now you have to aggregate all of the data from all these instances that you might have running and containers you might have running all over the place. You want to aggregate them in a very efficient manner, and then you want to store the data in a place in a very efficient manner, and then you want to be able to analyze it in near real time or real time if possible, and achieve your security functions, right? So the big the takeaway from this at this point in time is to think about the act of not moving away from the traditional idea of implementing security controls on the endpoint itself. Now that the endpoints are becoming very lightweight, very ephemeral, very dynamic, what you really want to be able to do is simply very efficiently extract the data and then do all the security control work off the endpoint. So this architecture, this thought process actually allows us to do that. So Osquery is very efficient at extracting all system metrics, and then if you have a way to do that at scale and land it at scale and analyze it at scale off the endpoint, now you'll be able to achieve all of your security functions that you have been that you need to implement. So that's precisely the approach that Upticks has taken. What we have done is allowed you to deploy Osquery at scale Osquery, because it's open source, very, very portable. It actually runs on all the known operating systems that we typically tend to see in use today. Everything from Apple Macs to Docker to Linux to Windows and so on. It has been ported to pretty much all the major platforms at this point in time. What Upticks does is it helps you deploy Osquery in your infrastructure at scale, and then automatically starts asking SQL queries of the Osquery endpoint and starts harvesting data from Osquery. In fact, we harvest enough data to actually be able to recreate the full state of the operating system at all points in time. So that's a pretty tall claim I'm going to make. Hopefully the demo will show you how real that claim actually is. Yeah. Now, the first thing that happens is when the data is streaming into our cloud platform now, we can apply some logic to it as it streams in, right? There's a certain amount of alerting and processing you can do just as the data comes in. So if, for example, somebody opens a socket to an IP address, it should be possible to verify that IP address against a database of known bad IPs. Or if a process launches, it should be possible to take the MD5 hash of the binary that just launched and immediately test it against VirusTotal to see if we just launched a piece of malware and so on. So Upticks, the first thing we allow you to do is we allow you to apply arbitrary lambda functions, so to speak, to the incoming data, so you can immediately fire off data over there, alerts, any alerts over there. Yeah. Oftentimes, though, you realize that the amount of the kind of logic and things you're looking for, the indicators of compromise you might be looking for, is a lot more complex than that. It's a bunch of correlated data and so on and so forth, right? So in order to achieve all of that, what we also do is we take this data and we store it in a specialized form. We call it the historical flight recorder store, but think of it as a way of storing the data in such a way that you as a person or an analyst can actually just say to the system, to Upticks, saying, hey, take me back to such and such 2 a.m. last Tuesday and show me the state of all of my operating systems at that point in time. And the flight recorder store, kind of like a black box on an airplane, will actually do exactly that. It'll take you back in time and say this was the exact full state of all of your infrastructure at this point in time. Yeah? In addition to all of that, since you have Osquery running on the endpoint, we actually allow you, if the endpoint is still available, we actually allow you to do a real-time query in case you're looking for some specialized piece of information that for whatever reason we didn't collect and so on. Now, so far, this seems very powerful, but it's still missing a really important piece, right? In order to actually make sense of this data, you want to actually correlate that with a whole bunch of threat intelligence information. There's a lot of threat intelligence data that's available out there, lots of open source feeds and so on. The problem is that there's lots of open source feeds and so on, right? So which ones are you going to actually correlate with? They all happen to be in a variety of different standard formats. Everything from a CSV file all the way to a TXT format with 300 different fields per IOC type of thing, and everything in between. So how do you really take all this wealth of threat intelligence data that we have available and use it to correlate with what's going on in your infrastructure? So what we have done is we have imported all these threat intelligence feeds and normalized the data, deduped it, cleaned it up, and maintained it, and made it available as a standardized set of SQL tables right alongside the data coming from Osquery, which also happens to be in SQL format, right? Making it easy to do the correlation. And now, given all this data that's available in Upticks, we actually now finally turn around and through our UI and reports and so on and so forth, we give you a out-of-the-box solution for intrusion detection, for file integrity monitoring, for incident investigation, vulnerability detection, and audit and compliance. Yeah. So with that, what I'm going to do is switch over to a little demo to show you both Osquery and what Upticks can do for you. So to start with, I'm going to give you a very brief tutorial on what Osquery is. As I mentioned, the inspiration for Osquery came at Facebook when they realized that the act of collecting information was proving to be extremely expensive. So as an example, let's say I'm an infrastructure engineer at Facebook, and my job is to come in and take a look at these 100,000 servers or whatever they're running and find out which servers had an incident overnight, right? Which ones crashed or rebooted overnight, and maybe I need to now then take a look at the servers to see why they did what they did. Yeah. So a easy way for me to find out if a server crashed overnight is to type in a simple command called uptime, right? So here, for example, I can say that this particular server has been up for 1 day, 8 hours, and 54 minutes. So clearly it survived the night, right? There's no problem on the server, and I can now go on to look at the next server and so on. Yeah. Now, the problem is if I had to do this across 100,000 servers, I'm not going to be able to do this manually by SSHing into each one manually and doing this uptime command and so on. So immediately I will start writing a bash script that will sit in a nice loop and SSH to all these machines and do the uptime command. But that's not where my job ends, because now that it's all automated, well, the 1 day, 8 hours and 54-minute data piece over here is easy for the human eye to consume, but not so easy for automation to consume. So now I'll have to feed the output of uptime into a Python script or something, strip out this information, put it in some data structure, sort it out, figure out all the servers that had uptime of less than 24 hours, and then finally maybe print an output saying, oh yeah, of the 100,000 servers, the following servers had an incident overnight, and rebooted overnight. But notice what just happened, right? My job is to figure out how to keep the servers up and running, but within 2 minutes of me showing up to work, my job has turned that into that of a software developer. I'm thinking bash scripts, I'm thinking Python programs, I'm thinking data structures, and so on and so forth, right? Hence the expense of actually just collecting data, right? So the inspiration for what Facebook did was they built Osquery. And what Osquery does, it just takes all this data and makes it very simply available in terms of SQL tables, right? So for example, uptime becomes a simple table, and I can simply say select star from uptime, and what comes back is still the same information, except now it's in the form of a SQL table. Okay, so it's 1 day, 8 hours and 56 minutes now, but you can see it's in the form of a SQL table. It makes it very easy for me to now formulate a SQL query that says select star from uptime where days equals zeros and hours less than 24, right? And that'll give me all the machines that have been up for less than a day. Yeah. Similarly, the power of this really comes from being able to access all information using the standardized SQL format, right? So, for example, now if I want something about processes on these machines, right, I can simply say select PID, name from processes. So process is just another table. I don't have to switch from the uptime tool to the PS tool with all the complicated flags and so on and so forth. I can just say select PID, name for processes, just treating processes as yet another database table. And what comes back is, again, the answer in terms of a database table. And you can see that Osquery can pretty much retrieve any and every piece of information using the SQL syntax over here. I no longer have to resort to a plethora of different tools in order to get the information. So, for example, if I want to know the contents of Etsy host, here's the content of Etsy host presented as a set of database tables and so on and so forth. So that's what Osquery does, is it basically allows you to get at all system information in terms of a SQL query. Now, the limitations, though, are as follows. As you can see, it's an endpoint agent. It runs on a single machine. So if you deploy to all your servers, more power to you. You don't need anything to do that other than Chef, Ansible, Puppet, or whatever you use to deploy solutions. But then once you have deployed it, you have to figure out how you're going to connect to these machines, how you're going to present the SQL query, how are you going to collect the data across all of them and process it. That infrastructure is something you have to build on your own. The second big limitation is that Osquery out of the box doesn't just start running a whole bunch of interesting queries for you. You have to figure out what queries to run. You have to figure out, what purpose you're going to apply that return data to, and so on and so forth, right? It's up to you to come up with the SQL queries, analyze it, and take action based on the conclusions you're drawing from the analysis and so on. So that's a big limitation, number two, right? And then, as I mentioned earlier, the third big limitation is that even if you have this infrastructure to collect information from all the Osquery agents you have deployed, and even if you knew all the SQL queries that you're going to run continuously and so on and so forth, you still have to marry it to a whole bunch of third-party threat intelligence information to draw conclusions and actually understand what's going on in your infrastructure. So it's pretty much what Upticks does for a living. So we help you deploy Osquery at scale. We automatically start sending out a whole bunch of queries and harvesting enough information to give you an out-of-the-box solution for intrusion detection, threat investigation, and so on and so forth. Yeah. So we are a SaaS solution, first and foremost. What that means is you can turn around and get started with us in a very short amount of time. All we need to do is create an account for you, and then typically you'll be logging in to your account in using your corporate ID. We support Google Auth. Most corporate identities today are Google Auth enabled. And if you're using some other SSO, we support all the big ones, Okta, Ping, and so on and so forth. Yeah. So, in any case, you log in using your corporate ID, and the first thing we'll do is, of course, welcome you, prompt you to get started. The way you get started is by downloading the right version of Osquery for your environment. So in my demo environment, I've got a whole bunch of Ubuntu machines running on AWS. I've also got a smattering of Macs and Windows laptops and so on. So Osquery runs everywhere. So this kind of a solution actually can be very comprehensive across your entire infrastructure. Although it really does, for the endpoints, you may have other competing solutions. But for the cloud, you really, as we mentioned already, you really need to start thinking about how to handle the ephemeral nature of the instances, the fact that you don't have access to the network anymore, et cetera, et cetera. So that's where this really starts shining and so on. Yeah. So now that it's downloaded, the Osquery is downloaded, what I'm going to do is run a very simple Ansible script to actually deploy this agent onto all of my machines, right? Now, if you're in practice, most people either use Chef Ansible Puppet, just like I'm doing right now, or they deploy it using Terraform or CloudFormation, et cetera, or they actually just bake it into the AMI image, the standardized AMI image they are using in their organization. So what happens is at that point, anybody who powers up a new instance, it automatically just connects, starts running Osquery, right? Now, what's in the package that's being pushed out over here is enough secrets and certificates and configuration information so that Osquery will not only start running if you install this package, but it'll actually connect back to your account on Upticks in a secure, authenticated manner. Now that the script has run, let's take a look and see what just happened over here. And what I'll see is that, exactly as I mentioned, all of my machines, 21 in this case, have started running Osquery and connected to my account in a secure, authenticated manner over here. Yeah. If I take a look at the machines that just showed up, you will see that there's a Linux machine, some Windows machines, some Macs, and then, of course, a whole bunch of Linux machines running on AWS, right? If I take a look at one of them, for example, it's 3:56 p.m. East Coast time, and I'll see that it's actually 3:55:58 was when this first enrolled, literally just a few seconds ago, yeah? So the point is, with Upticks, what we've done is made it very easy to scale, in a scalable way, deploy Osquery and get up and running. So all it took is to take the one and only package you download from Upticks, push it out to all your endpoints, and at this point, you're actually kind of done. Okay, all of the functions I was talking about, intrusion detection, threat investigation, et cetera, are actually working over here. You can see that I've already gotten an alert saying one of my Macs seems to have an OS X malware on it, and I'll tell you how that just happened over here. Yeah, what really happened, as I promised earlier, is that Osquery, Upticks actually started running a whole bunch of queries in the background as soon as I deployed Osquery. So in the case of the Mac, for example, it's running these 132 queries, all on a very finely tuned schedule and so on and so forth. So you don't have to worry about configuring all of this stuff. It just comes out of the box for you. Similarly, in the case of Ubuntu, which is the Linux version I'm running on my AWS, it's running these 96 queries. And again, these queries have all been finely tuned and designed in such a way that Upticks, given the responses to these queries, actually has an ability to recreate the full state, has full visibility to what's going on in your machines at all points in time. And that's going to be a really powerful concept to do, yeah? To give you an idea of what it feels like to do a query, I'm just going to do a couple of real-time queries real quick. So what I'm going to do is, since I showed you select star from uptime on a single machine, I can show you what happens with Upticks, right? So in this case, I'm actually able to query all my machines at once instead of doing it one by one, right? So I select star from uptime and the answer snaps right back, right? So here's Georgia, it's been up for 70 days and so on and so forth, right? Here's a Mac machine that's been up for 173 days and so on, yeah? Let me show you something with a bit more data in it, yeah? So let's get all processes from all machines, right? So this is going to go across all of my entire infrastructure and ask for all running processes on all of those machines, right? So if you're familiar with Tanium, they sort of popularized this question, this notion of being able to ask the question of your infrastructure in real time. So with something like Upticks, you can actually do exactly the same thing, except you can see that the Tanium advertises, I think, 15 seconds or 30 seconds or something like that. And you can see in our case, let me just run it again. In our case, the answer sort of snaps right back, faster than, usually faster than the webinar can actually update the screens to everybody's machines and so on, right? So here's Georgia, it's running 119 processes. You can tell it's Linux because it's running things like systemd and so on. And here's a Mac machine that's running 106 processes. You can tell it's a Mac because it's running things like launch T, Apple events, and so on and so forth, yeah? The reason for the speed with which we can collect this data across an entire infrastructure is because Upticks itself is built like a CDN. like an Akamai, right? So just like Akamai can handle hundreds of millions of browser connections and sort of flawlessly stream Netflix movies down to all of them simultaneously, in the same way, Upticks infrastructure is built like a CDN, and we can handle literally a horizontally scalable number of voice query connections coming up to us. And instead of streaming movies down to the endpoint, what we're doing is streaming system data up to Upticks. So what's really going on is that in the background, we are running all these queries in the background that I just showed you. And the answers to those queries are being continuously streamed up to Upticks in a seamless manner. Yeah, and as you can see, the speed with which we can collect this data is actually quite high. Yeah. Now, in addition to some of those queries, we're also running a whole bunch of
Milan, are you speaking right now? Because we can't hear anything. Hey, Dave, can you hear Milan? I can't hear him right now.
I cannot hear anything at the moment.
Okay, I'm assuming he's still talking. I don't think anybody else can hear him either. So let me see if I can get his attention. Okay, I just got a note that he's aware and trying to fix it. Let's see. Dave, let me take a look here.
I'm back, guys. I'm sorry about that.
Oh, there you go. There you are. Okay.
Yeah, I'm so sorry. I fat-fingered something and I lost audio connection there. Apologies for that. So without further ado, I'm just going to keep driving right ahead. So what I'm going to do is run a little script called Havoc that I've written. And what this Havoc thing will do is it'll actually create a real-world situation in my environment. It'll actually take a couple of my Linux machines and it'll actually compromise them. It will attack them and put up a cryptojacking piece of software on those two machines, basically using my Amazon dollars to compute Bitcoins. And then eventually, when those Bitcoins have been computed, we'll transmit them back out to IP addresses belonging to quote unquote trading companies registered in Hong Kong and Australia and things like that, right? It's a surprisingly common type of attack that we see, especially on these cloud environments with lots of machines that people sort of don't necessarily maintain with the higher standards and so on and so forth. Yeah. All right. So that's what's going on. Now, what's happening on our side, of course, is that Upticks is running all these queries in the background, as I've said a couple of times already. In particular, for Ubuntu, we're running these 96 queries. I have full visibility into everything going on in on all of my Ubuntu machines in this particular case, right? So, and that includes everything, not just the static information about how the machine is configured, but also everything about what processes it's running, what I/O is going on, what sockets it's creating, and so on and so forth. Now, in addition to that, what we have done is we have imported a whole bunch of threat intelligence information directly into Upticks, right? So you can see we have over 40 different sources of indicators here, over 6 million different pieces of indicators of compromise, everything from phishing URLs to newly algorithmically generated domains to bad IP lists and so on and so forth, right? Over 6 million pieces of that. What we have done is, as I mentioned earlier again, it's normalized all of that, standardized it, cleaned it all up, deduped it up, and put it all in a single database table, SQL table, right alongside all the OS query data that's being harvested continuously. So what's going to happen now is it becomes very easy for Upticks to be able to correlate the two pieces together. So as a direct result of that, you can see that Upticks is flagging to me that it just detected a suspicious activity and activity to a suspicious IP address on a couple of my machines over here. Okay, so this kind of stuff, as you can see, just works out of the box for you, right? You as a customer had to do nothing. While I was walking you through how the system is working and so on and so forth, at the end of the day, as a customer, you don't really have to worry about all of that stuff. It just comes out of the box, and all you have to do is install this one package that you downloaded, put it on all your machines, and Upticks and Osquery will start doing the rest. It will start harvesting data, correlating it with this known threat intelligence sources, and so on and so forth, and giving you alerts as and when required. Yeah. Speaking of alerts, these alerts will actually also be delivered over a Slack channel, email, PagerDuty. All of that has been integrated directly into Upticks and so on. Yeah. So as you can see, I just got a couple of alerts to those bad IP addresses that were fired as part of my demo over here. Yeah. So now that I have this alert, of course, the next big question is now I need to investigate this. I need to understand the depth of this attack. Okay, is it just a scan? Has the attacker actually been able to break in? If they've broken in, have they been able to put software on my machines? And God forbid, have they already started exfiltrating data, et cetera, right? So you have a whole ton of questions about that. And in order to do that, I'm going to go into my investigate panel and then start investigating the situation over here. Yeah. So the first thing I'm going to do is I'm going to figure out who's connecting, which machines are actually connecting to this known bad IP address. Okay. So because it's an urgent situation and we're in the middle of a very big demo over here, I'm just going to go and do a real-time query and go to all of my machines right now and say, hey, which ones of you are connecting to this known bad IP address? Now, luckily for me, Osquery has a very convenient table called process open sockets. It basically records every single socket that's been opened. So all I have to do is filter through everybody's process open sockets table, looking for anybody that has a connection to this particular bad IP address. Yeah, pretty straightforward concept over here, and I'm going to do that in real time, so that should go very fast. And here comes the answer, and they're all the zeros. Boy, I'm not doing too good today on this webinar here. Let me try again. Okay, so guys, I think I have a bit of a problem over here. You can see that Osquery is basically saying that nobody has an open connection over here. Yet at the same time, let's make sure the IP address is correct, 54.165.17.209. It definitely gave me an alert about connections being made to that IP address. So how can that be, right? How can it be that when I ask Osquery, hey, who's connecting to this bad IP address, right? It's saying nobody's connecting to it, but yet at the same time, I clearly got an alert about that. So what's going on over here? So what just really happened here is probably because of my audio interruption over there, and the couple seconds it took me to recover from that. What's happened is my script that was doing the attack has actually completed running. Okay, so even though there was an attack that happened in the past, right now the attack is not happening currently. So when I ask Osquery right now, there's no information about any connections being made, right? If you now extend this problem to what happens in the real world, right? Attacks happen at 2 in the morning in the real world, right? So you're not going to be sitting around at 2 in the morning typing in queries anyway, right? And as Dave has mentioned, right, these machines and instances might be up for 20 minutes, an attack happened, and then the machine was shut down because the load went away, et cetera, et cetera. That's the very nature of cloud. Cloud is all about elastic computing. So you grow the number of instances when the demand goes up, and then you shut them down when the demand goes away. Meanwhile, if an incident happened while the system was up, after it was shut down, now as a security incident response team, how are you supposed to investigate if the system itself has disappeared off the face of the earth, right? So luckily for us, this is where Upticks is adding real value over here. Yeah? So what we have done is taken all the data that we have been continuously harvesting and put it in a big data store in a very specialized format. As I mentioned, we call it the flight recorder format over there. Yeah. So all I really have to do is take the exact same query and point it at my historical store. I don't care that the machine may not even be available at this point in time. I have taken all this data and put it up in my historical store, and lo and behold, here's all the answers to the connections that were to my question about which machine made the connections, right? So you can see from here that it was the New York and Baltimore servers that actually made those connections, and I have the full record over here. Here's the remote address that I was looking for, the local address, local ports, remote ports, protocol, et cetera, right? Now, of course, as an incident responder, the most important thing I'm trying to answer at this point is, hey, who actually opened this connection? What process actually did that? And you can see that I have some process IDs over here that uniquely identify the process, but that doesn't, tell a human being much about anything, right? So what I'm going to do next, luckily for us, is rely on the fact that Upticks has gathered every piece of information about the system. Not only what sockets were open, but also what files, what I/O was going on, what processes were running, what users were logged in, and so on and so forth, right? So all I have to do is now take the exact same process ID and use it to join into the processes table and pick up the name of the process from my historical store. And here comes the answer. Looks like it was consistently the netcat process that was actually running that opened these sockets. So now I'm getting a little worried because, we all know netcat can be is a very popular tool for doing things like reverse shells and exfiltrating data and so on and so forth. So the first thing we might want to answer is, hey, which user account was used to spin up this netcat process, so I can figure out what privileges it had. So in this case, I'm going to take the UID from the processes table and join it into the users table to get the username and so on, right? And here comes the answer. It was, in fact, looks like the MSHA account that was used to spin up the netcat process and so on and so forth, yeah? So what you can see over here is because of this global store that we have, you can actually recreate or you can investigate an incident that has happened way after the machines have been shut down or have disappeared and so on and so forth, right? Or might be offline, etc. So you can get a complete historical store over here. Now, we have gone one step further. Oftentimes, when you're doing an investigation, what you're really trying to do is limit your querying to a particular scope of time, right? An incident happened at a particular time in time of window, and you're trying to understand what was going on at that point in time, right? So you can always write raw SQL queries where you have restricted, the range with time and so on and so forth. With Upticks, we have given you a time machine type of an interface, which allows you to use this slider to set the time window in which you want your queries to run, and then you can run pretty much the same queries over here and get the answer. So here, for example, I just set it to a smaller time window, but of course I got all the data, but I can equally well draw it out to somewhere way in the past, right, a couple of days ago when the demo system didn't even exist, and say run. Of course, the system will find no data from that point in time. So it should come back with no data, and there you go, right? So as an incident investigator, all you have to really do is adjust this slider to approximately the time of the incident, and then query away as if you're querying your infrastructure in real time at that point in time. That makes the act of incident response very, very easy to do. For my final piece, I'm going to actually switch over to a different system that has a little bit more data available for me to show. So one of the questions that, one of the things that you can do with the fact that everything about your system has been recorded in this historical store is you can actually meet your compliance objectives as well. So once again, compliance has the same problem as incident response, right? Your compliance auditor shows up once a year, maybe once a quarter, and says, great, now let's take a look at all the machines you've been running over the last 3 months, make sure that they were all compliant with whatever regulations they have to be compliant with, yeah? The problem is those machines are gone, okay? They were spun up for 17 minutes and they're gone. So how are you going to demonstrate that they were compliant with whatever they're supposed to be compliant with, yeah? With a strategy like what Upticks is using, all of the machine's data, including the configuration data, et cetera, has been stored in this global store. So you can very easily pull compliance reports straight from this global store, right? Even if the machine is online, offline, has already been taken off, and so on and so forth. So as an example, we have shipped a whole bunch of compliance reports, CIS, FedRAMP, SOC 2, PCI, and so on and so forth, straight with the product. And when I pull up the report, what it's actually going to do is actually going to query the database and say, okay, in this case, it's I pulled up CIS benchmark 1.4, which has to do with secure boot settings. So it's testing to make sure that the boot settings of all my instances was properly configured. In this case, it determined that there were 79 machines under scope of this compliance report, right? And then it started running checks. The first check, for example, from the CIS benchmark is to ensure permissions on bootloader config are configured properly, right? Now, CIS, for those of you who are familiar with it or not familiar with it, it's very prescriptive. It tells you exactly how to check for that. It tells you, in order to check for permissions on bootloader config, first you do a stat command, make sure that this file, boot grub menu.lst exists. And if it does, make sure the permissions are set to 600 with user ID and group ID set to 0, right? In my case, I can see that all 79 machines failed. And I can see that some of them failed because the files didn't even exist on the machine. Others failed because the file did exist, but the permission was not set correctly. The permission was in fact set to 644 when it should have been set to 600, and so on and so forth. So you get the general idea that since we have all the data about all these things sitting in our global store, it's a matter of formulating the right query to be able to figure out whether you're compliant with something or not. Yeah. So with that, I'm going to summarize once again that Upticks is the fastest way to deploy Osquery at scale, very appropriate for a cloud and Docker type environment. And then once it's deployed, it starts harvesting data, puts it in the global store from which you can do intrusion detection, from which you can do threat investigation, from which you can do compliance reports, also file integrity monitoring and vulnerability management, and so on and so forth. Yeah, because all of the data has been done offline, and you are able to respond to it using the database store that we have created. Yeah. With that, I'll open it up for questions and hand it back to the moderator. Carol? Hi, Carol. Hello?
Hello, I can hear you. Go ahead. Oh, you're ready?
Sorry.
Oh, okay. I think I missed your last sentence, and it sounds like you were summoning me. All right, you want to go ahead and bring us back to the slide deck, Milan?
Yes.
Okay, great. All right, so yes, thanks for that great presentation. So we have some questions ready for the Q&A. However, if anyone has a question for our presenters, please enter it into the questions window now. Our first question is oh, sorry, just scrolled out of view. Let me click on it here. Is the historical flight recorder part of Osquery or something custom to Upticks?
That's a great question, right? So Osquery in and of itself doesn't actually have any historical data. So when you send a question to Osquery, when you ask a SQL question off of Osquery, let's say select star from processes, what it's actually doing is it's taking that query and then actually executing the same code that, let's say, a PS command might do at the time you ask the query, and then will return the list of processes in that case running at that point in time. There is no historical store. There's no local store at all with Osquery. It's purely giving you the current state of the machine. So the idea of a flight recorder is completely proprietary to Upticks, I should say. Of course, Osquery itself is free, so it's an open source. So you can configure Osquery to run queries on a schedule and take the output and dump it into Elastic and something along those lines. So you can potentially you might be able to put something like that together. It does. What we have found is that the specifics of the data that comes back from Osquery requires you to do a fair amount of work to actually pull off the ability to figure out the state of the tables at all points in time. But yes, the brief answer is the flight recorder is proprietary to Upticks. It's something that someone like Upticks or yourself would have to build on top of Osquery.
Okay, thanks. Can queries be run remotely? Are query responses encrypted? And what is the method of authentication?
Excellent questions, right? So yes, so when I showed you the ability to run a query, so when I came in to investigate and I ran a real-time query, right? What I was able to do, what really happened over here, so when I say select star from uptime and I choose to go real-time, what's going on is this query is actually going to the Upticks cloud. Upticks cloud, using its CDN type architecture, is distributing the queries to all of the Osquery agents, and then collecting the answers from the Osquery agents and then presenting it back to the UI, right? So yes, it is possible, definitely possible to run queries remotely. You do need to build a very specialized kind of backend that Osquery knows how to connect to. So the protocol that Osquery uses to connect to any backend, including Upticks, is fully documented. So it's a RESTful API type of thing. So it makes those calls, and then you can use that to execute queries remotely. The transmission of the data is completely encrypted. So it is the connection that Osquery makes to the backend is all standard HTTP TLS 1.2. So it is the latest version of HTTP TLS, and it is encrypted that way. In terms of authentication, first of all, Osquery will authenticate. So when you deploy the Osquery package, it is best practice to deploy a public CERT of the server that is going to connect to with the Osquery package, so that it will validate that the server is connecting to can present the correct CERT back to Osquery, right? So Osquery will authenticate the server. Now the server itself is able to authenticate Osquery itself, but that is not X509 certificate based. It is basically a key that is distributed with the package, Osquery package. So Osquery, when it connects, validates the remote server, it will present the key, and that key should have enough information for the backend to validate that this is a legitimate Osquery agent coming in. So that's how that works, right? And how you distribute the keys to Osquery is something that's left to people like Upticks to decide. And I could go into more detail about that, but I think that it should get you the general idea. There is a key-based authentication.
All right, thank you. Any on-prem options can't go public cloud, TIA?
Yeah. So we, as Upticks, we have an on-prem and a cloud option. So what I just showed you was the cloud, of course, but you can take the exact same bits that we ourselves run in the cloud, and we can provide it to you. We actually, our largest customer, in fact, is an on-prem customer, and we have several other customers that use Upticks in an on-prem manner. So in that case, what we do is we take the exact same bits that we ourselves run on the cloud, and we bundle that up and give it to you along with a single script. The single script that you run will install the Upticks solution onto your machines, presumably in your own data center or perhaps in a VPC or whatever, right? Wherever you choose to install it, and then you will essentially have a captive instance of the product I just showed you. So there is definitely an on-prem option available. And it's the exact same bits. We don't have a separate, binary or product. It's the exact same bits that we ourselves run in the cloud. We give it to you.
Okay, thank you. Is SaaS the only option, or can Upticks be run on a local network or VPC?
Right. So I think, as I mentioned just in the previous question, SaaS is the most popular option, but we can give you the Upticks software itself, and then you can run it on a VPC. You can run it on your private data centers if you wish. Yeah. As a word of warning, it is a pretty, like I mentioned, it is a pretty heavyweight backend. Upticks is a pretty big solution on the backend, pretty much a full CDN. So it probably makes sense to do the on-prem version once you get past about 50,000 nodes being managed. Something past that, and then it starts making more sense to use as an on-prem or in your own data, on your own network or your own VPCs. For anything smaller than that, probably the overhead to you to maintain Upticks will probably exceed the any cost benefit thing over there.
All right, thanks. This next one says, Milan keeps mentioning the response time, speed, and how fast things are in real time, but the demo is only dealing with 21 assets. How does performance scale across 100,000 assets?
Yep. Again, a fantastic question, right? So in order to do that, I don't know if I have a slide handy at this presentation, but to understand that, you have to imagine how a CDN is built. So a CDN, so if you're familiar with something called consistent hashing, that's sort of the trick behind building a CDN. So what's really happening on the back end is that we have automatically, as more and more Osquery agents connect up to Upticks, we start spinning up more and more instances of our software automatically, right? So we spin them up, and they start fielding the next incremental set of Osquery agents and so on. Without going into too much detail, mathematically, such a system, if built in a simplistic manner, where all I'm doing is spinning up more and more instances, right, as the load increases, is actually mathematically going to be unstable. Why? Because let's say one of the systems goes down, what will happen is the Osquery agents that it was servicing in this case will try to redistribute themselves to the next. They'll start hunting for the next server. And if you're not careful or if you're not smart about it, what will happen is the fact that on the next server, the load suddenly doubles because the load from the failing server has suddenly moved over to the next server, will probably cause that server to fail as well. And now there'll be two guys looking for the third server and so on and so forth. So you can actually bring down the entire CDN if all you have is unmanaged attempt by your clients to try and hunt and find the next available server type of thing. So the problem was mathematically solved using something called consistent hashing. So what happens is when a server fails and Osquery says, oh, I got to find another one, there's an algorithm, a consistent hashing algorithm that is applied, which mathematically will distribute all the Osquery agents from the failed server uniformly across the remaining servers, right? And so the load very seamlessly increases and very incrementally increases on the remaining servers until the failing server can be brought back up again. But basic idea is because of this kind of a technology, the backend can scale pretty much infinitely up and down as well in case servers start failing and so on.
All right, thanks, Milan. There's several questions here that came in during the demonstration. I'll read through them, and if we need clarification, perhaps the person can resend it. But someone said, so we can see it in the time machine. And I think they're referencing
could you repeat that, please?
They said, so we can see it in the time machine. But if that's not, if that doesn't make much sense, we'll have them rephrase it and move on to the next one.
Yeah, I don't know. See it. What does the it refer to?
Okay. All right. So David, if you could send that in if you still need clarification. Okay. The next one is, how often is Osquery sampling these points in time?
Yeah, that's an excellent question. So I'm going to switch back again to the configuration. So over here, so you can see that the frequency with which Osquery, or actually Osquery itself doesn't do anything proactively. So it is up to Upticks in this case who is asking the SQL questions to indicate to Osquery how frequently to answer those questions, right? So in this case, for example, I'm saying select star from ACPI tables, and I'm asking that question once every 60 minutes, right? And the next one, APT sources, I'm asking once every 330 minutes and so on and so forth, right? If I look at something like, let's say, processes or process open sockets, you'll see that I'm asking that every 30 seconds and so on and so forth, right? So basically, the interval with which I'm asking this question is tuned to be different. And you again, this is not by accident. This is carefully designed because what we have done over here, and we have used intervals, if you notice, kind of odd intervals like 330 minutes, as if we could count to 6 hours type of thing, right? So why 330 minutes, right? So the reason for that is if you look at the way we have organized all these queries, the load on the Osquery remains sort of constant throughout, right? So Osquery, when you deploy it with these kinds of configurations and so on, you'll see that it uses a very small amount, about 3%, between 1 and 3% of your CPU resources on a typical machine, and it stays at that level on a constant way because it's got a constant amount of work to do, and there's no cyclical spikes and so on and so forth because of this design, yeah? Having said that, there's another question that I'm sure comes up, right? Which is, wait a minute, if you're querying everything, let's say the most aggressive you do is every 30 seconds, every 5 seconds even, doesn't really matter. What happens to the data that the events that happen between those 5 seconds or 30-second intervals, right? So let's say a socket was created and then closed. Between the times I was actually asking Osquery for socket information, then will I not miss that particular instance? So in order to solve that problem, Osquery actually has a second set of tables which work a little bit differently. So those tables are called event tables. And the way those tables work is the first time you ask information, so let's say select star from file events or process events or socket events, it'll give you nothing. But the second time you ask, it would have recorded all the events, all the process or socket or file, etc. events that have happened between the first time you ask the question to the second time you ask the question. And when you ask the question the second time, when you pose the query the second time, it drains all the events that have been recorded between the two query intervals, right? So by doing this, by enabling events, and of course the underlying information in the world of Linux comes from the kernel audit system. so people will know where this information is coming from, right? So it's basically Osquery can take over from audit D and then pump all those events out to us, which is why we can we make the claim that we can recreate the full state of your machines at all points of time. It doesn't really matter what our query intervals were. The query intervals in that case is simply managing the buffers the buffer size of Osquery. So the more frequently you query that, the smaller the buffers will be because it's accumulating fewer events, right? So that's what the tuning is all about there.
All right, well, we're just about out of time, so I'm going to go ahead and launch 2 polls. Select this first one. So the first question is, would you like Upticks to follow up and schedule a personal demo, yes or no? I'll give you guys about 30 seconds. All right. Now on to the second one. Are you or a colleague planning to attend AWS Reinforce this June in Boston? All right, while I let the one run, I would like to thank Dave and Milan for your great presentation, and to Upticks for sponsoring this webcast, which helps bring this content to the SANS community. To our audience, we greatly appreciate you listening in. For our schedule of all upcoming and archived SANS webcasts, including this one, please visit sans.org/webcasts. Until next time, take care, and we hope to have you back again for the next SANS webcast.